So, good evening everyone. My name is Sourav and I welcome all of you to this Gate Booster series on the subject heat transfer. As you know, that heat transfer is one of the most important subjects when it comes to mechanical engineering, and it carries on an average 5 to 8 marks, as I already said. Now my dear friends, what you can expect from this session? See, at this stage, that is December, almost mid we are here, I am expecting that all of you are thorough with your basic concepts. All of you have done or at least have gone through the PYQs and certain types of extra questions that wherever you are studying you must have gone through. Today I have taken all the new questions for heat transfer, and I have tried to include as many topics as follow. Yes, including all the chapters, as many topics that I can cover, or all the important topics that I can think of in my opinion that can come or has a good chance of coming in the examination, that I have taken. You can expect some 12 to 13, 12 to 15 questions on an average I have taken, and all are new, and we will be doing, and I'm sure that once you do these questions you will definitely have some confidence facing the heat transfer questions in the examination. And this is the purpose of the Gate Score Booster series. So far, whatever questions or whatever sessions that you have been seeing from our faculties, the only purpose is that the only purpose is that you have the confidence, you have some confidence going into the examination, right? So yes, good evening Atul, very good evening. Fine. So my dear friends, you can join our Telegram group, and I'll tell you that every day on our Telegram you will be having quizzes, many questions. So you can definitely you will be benefiting all the PSU and government job notifications you will be getting. So if you join, you will be definitely benefit from the our Telegram. Gate 25-26 program, live online program, you can definitely join, wherein you will be getting 800 hours of live classes, some theory book, exercise books, and 30 years PYQ with video solutions you will be getting, and then personalized one-to-one mentorship sessions you will be getting. So all the benefits you will be getting, and I recommend that if you wish to prepare, so definitely you can consider joining, right? So now my dear friends, without wasting any time, yes, very good evening Mr. Christine. So without wasting any time, what we are quickly into this, So let us see, my dear friends. This is the first question, and what I'll be doing, I'll be simply showing you the question, and for 2 to 3 minutes I am giving you time so that you can do question or whatever concept you want to apply in your rough copy. You can apply, and if you get the answer, you can let me know. If you don't get, I'll be anyway solving it. So here is the first question, my dear friends. Gate Booster series, the first question of heat transfer. Yes, on your screen. Yes. Yes. So what the question is saying? The question is saying that consider a long solid cylinder of radius r naught equal to 4 centimeter and thermal conductivity K is equal to 25 watt per meter degree centigrade. Heat is generated in the cylinder uniformly at the rate of 35 watt per centimeter cube. The side surface of the cylinder is maintained at a constant temperature of T1 is equal to 80. The variation of temperature in the cylinder is given by this relation, as you can see. And which of the following options is or are correct? So option A is the heat conduction is transient in nature. Option B, the heat conduction is steady in nature. Option C, the heat transfer is three-dimensional. And option D, the value of the heat flux on side surface of the cylinder at R equal to R naught is this. So I have already got one answer. Pragyabrat has given that it is B and D, and let's see that what is the answer. Any more answers before I start solving? Okay. So the relation, what I am doing is, I am writing the relation is given as TR is equal to G dot R naught square by K 1 minus R by R naught square plus TS. So before going to the ABC options, let us first find what requires some mathematical calculation. So let me find the heat flux. So my dear friends, you know that heat flux is given by minus K dt by dr. Now in the radial direction, the temperature is changing, so I am using dt by dr, and you can see from here that it is varying with respect to r. So what I will do, I will first find dt by dr and I will then substitute r equal to r naught. Okay. So minus K, and what is dt by dr? So dt by dr, so simply differentiate with respect to r. So Ts is constant, so it will be 0. So r naught square by K, 1 is 0, 1 differentiation 0 minus 2r by r naught square. Again Ts will be 0. Okay, so minus and minus is plus, so that is gone. Minus and minus is plus, and what are the terms which I can cancel? K and K gets cancelled. R naught square gets cancelled. Plus and plus is there. So what is left? I think 2r G naught is only 2r G dot is only left. 2r G dot is left. So 2 r is what? R naught is 4 centimeter. At r equal to r naught, see over here, at r equal to r naught I need to find out. So into r naught into G dot. And 2, what is r naught? R naught is 4 and G naught is I think 35. So that is centimeter, and that is centimeter into 35 is what? Watt per centimeter cube. So ultimately you will be getting 280 watt per centimeter square. So what is the flux? The flux is 280 watt per centimeter square. So yes, D is the correct answer. Now, heat conduction is transient in nature. Has it got any time term in it? No, there is no time term in the temperature. Temperature is not varying with respect to time. So I can say it is steady, not transient. It is steady in nature. So transient in nature, no, that is the wrong answer. Heat conduction is steady in nature. Yes, that is correct. Steady. It is steady in nature. Very good. And heat transfer is three-dimensional. When do we say heat transfer is three-dimensional? I will say only when it is varying in the 3 dimensions. Like x, y, z in Cartesian. In cylinder it might be, r, theta and some z. So no, it is varying with respect to r only. So it is one-dimensional. It is not three-dimensional. So C is wrong, and D we have just calculated. It is correct. So your correct options are B and D. Your correct options are B and D. Very good, Pragyarat and Mr. Loki Christine. You have given the correct answers. Very good. Very good. Yes. So I hope no doubts are there in this question. And let us proceed for the second question, my dear friends. I hope no doubt is. So yes, that was an MSQ question. The first question was an MSQ question. The first question was an MSQ question. Okay. Without wasting any time, let us proceed to the next question, and this is the next question that is there. Please read. Please read. So this is an NIT question. So you can give your answer close to 1 decimal places. So what the question is saying? The question is saying that consider a 1.5 meter high and 0.6 meter wide plate whose thickness is 0.15 meter. Whose thickness is 0.15 meter. One side of the plate is maintained at a constant temperature of 500 Kelvin while the other side is maintained at 350 Kelvin. The thermal conductivity of the plate can be assumed to vary linearly in that temperature range as given. Kt is equal to K0 1 plus beta T, where K0 and beta values are given. Now disregarding the age effects and assuming steady state heat transfer, determine the rate of heat conduction through the plate. Yes, that is NAT. Yes, that is an NAT. Yes. Anyone with the answer? Anyone with the answer? Should we discuss? Okay, so let me discuss. So he's saying that consider a 1.5 meter high. So let's say this is a 1.5 meter high, and width is given as 0.6 meter. So this is 0.6 meter, and this is 1.5 meter high. 1.5 meter high. Something like this. And thickness he has given as 0.15 meter. Thickness he has given as 0.15 meter. Okay, Christine has given 2363. Let us see. Loki, let us see that what is the answer. Good name, by the way. Okay. So 0.15 meter. Now one side of the plate is maintained at a constant temperature of 500 Kelvin and other is 350 Kelvin. So let's say this is 500 Kelvin and the other side is 350 Kelvin. Okay. The thermal conductivity of the plate can be assumed to vary linearly in the temperature range, which is K naught 1 plus beta T. K naught 1 plus beta T, where K naught and beta values are given, disregarding the age effects, and what is the rate of heat conduction through the plate. What is the rate of heat conduction through the plate? Okay. So my dear friends, see, your K is varying. Your K is varying over here. Your K is varying with respect to temperature over here. So what to do? Now, if you have read this concept of varying thermal conductivity, so you use which formula? That K average A del T by K, del T by L, del T by thickness or L, whatever I want to write. K average. The same formula of slab I will use. I'll use the same formula for slab, but only thing, instead of K, which was constant in the formula, I'll be using K average. And what is K average? Your K average is the K value at an average temperature. The K is nothing, the K average value is nothing but the K value at average temperature. So K is given as K naught 1 plus beta T. So what will be K average? K average will be K value at average temperature. That means K naught 1 plus beta and T average. Your T average. So K naught 1 plus beta, and what is T average? T average will be 500 plus 350 divided by 2. So K naught value is given as 25. So should I write it over here? Okay. So K average is given as, okay, no issue. Let me take it to the next page. K average is, K naught is 25, K naught 1 plus beta. What is beta value? Beta value is given as 8.7 into 10 to the power minus 4. 8.7 into 10 to the power minus 4. And what is the average temperature? That is 500 plus 350 by 2. 500 plus 350 by 2. So this, if you solve it, I have already done the calculation, so I'll directly write the value. You will be getting as 34.24 watt per meter Kelvin. And once you get K average, you can very easily put over here. So it will be Ka delta T by L. So what is K? K is nothing but 34.24. Now what is the area? Area is the cross-sectional area. That means 1.5 into 0.6. 1.5 into 0.6. This is the area that you need to take. Okay. So 1.5 into 0.6. And temperature difference is nothing but your 500 minus 350. And what is the L? There is the thickness. The thickness is 0.15. So if you solve this completely, you will be getting close to 30,820 watts. 30,820 watts, or it is nothing but 30.8 kilowatts. 30.8 kilowatt you will be getting. Why K average? If you substitute, kisi K is varying over here. Mr. Locky Christine, K is varying over here. When K is varying, see, after integration, you are correct. You have integrated K with respect to T, that is 100% correct. But after integration also, that you will substitute in place of K, you will ultimately get it that K value comes out to be K average. You have integrated, that is correct. After integration, the final term that you will get, be getting over there, the K value that you will get, that is nothing but the K average. I have written the final result. Integration करने के बाद भी you will get the same. You should get the same answer. You must have done some calculation error. That's why you are not getting the answer. Is it clear? Can I move? Integrations, you can proceed by integration also. If you don't want to proceed by K average concept, integration say you can proceed, you will be getting the same answer. Anyway, moving ahead, I hope no doubt is there. Moving ahead, let us check the next question. Now I suggest everyone that you are trying the questions very good. If you are not getting the answer, immediately leave that question and proceed for the next question. Right. So now it's the time to read another question. Yes, so what is the question saying? The question is saying that consider a person standing in a room at 20 degrees centigrade with an exposed surface area of 1.7 meter square. The deep body temperature of the human body is 37 degrees centigrade and the thermal conductivity of the human tissue near the skin is this. The body is losing heat at the rate of 150 watt by natural convection and radiation to the surroundings, taking the body temperature 0.5 centimeter beneath the skin to be this. Determine the skin temperature of that person. Determine the skin temperature of that person. Anyone with the answers? Anyone? Okay, so I think it's time I should discuss. So from what he's saying, the body is losing heat at the rate of 150 watt by natural convection. Now see, let's say taking the body temperature 0.5 centimeter beneath the skin. So this is the skin layer. Let's say this is the skin layer. 0.5 centimeter below the skin layer, the temperature is 37 degrees centigrade. That means I can assume it's a kind of hot. From there, the body loses heat. From 5 centimeter below the skin, let's say this is the skin. Let's say this is the skin. This is 5 centimeter. This is 5 centimeter. This is the outer skin. This is the outer skin that I'm saying. This is the outer skin. 5 centimeter below the outer skin. Here the temperature is 37 degrees centigrade. From here the body is losing heat. When the body is losing heat, it will be losing inside the skin. Due to what? Due to conduction. Due to conduction through the skin. So K value is given as what? K value is given as 0.3 watt per meter degree centigrade. Okay. Once it is exposed to atmosphere, from here the effects of radiation and convection will be taken into consideration, and he is saying that the rate of heat transfer is 150 watt by natural convection and radiation. Okay, so all the things are given. Exposed surface area also he has given. What is the surface area? 1.7 meter square. Now he is saying that what is the skin temperature? That means What is the skin temperature? That means what is this temperature? What is the skin temperature? What is this skin temperature? So with all the details given, you can clearly see that I have to simply apply the steady state conduction formula, that is Ka Q is equal to Ka delta T by L. I have to simply apply this formula and get one of the temperatures. I have to simply apply this formula. So what is Q is equal to Ka T1 minus T2 divided by L. So if you put over here, I know all the things. 150 is equal to K. K value is 0.3. K value is 0.3. And what is A? A value is given as, area is given as 1.7. 1.7. And what is T1? T1 is 37. Minus, what is the T2? T2 is T skin divided by L. What is L? L is nothing but the, the thickness. So 0.5 centimeter, that means 0.005 meter I can write. And if you put all the things, the TS value will come out to be 35.5 degrees centigrade. 35.5 degrees centigrade. So which makes A as the correct answer. A as the correct answer. I got no answers for this. Why? Is it visible? Is the audio and all visibility is clear? Is the audibility and visibility clear? Okay. So should I proceed? Should I proceed? Okay. Because I cannot see your comments over here. Okay. I cannot see your comments over here, so just a minute. Okay, no issues. ठीक है. So this, now the next question comes. This is the next question. Please. Yes. So what the question is saying? The question is saying that. Please read the question. What the question is saying? The question is saying a 5-meter internal diameter spherical tank made up of 1.5 centimeter thick stainless steel whose K value is 15 watt per meter per degree centigrade is used to store iced water at 0 degree centigrade. The tank is located in a room whose temperature is 30 degrees centigrade. The walls of the room are also at 30 degrees centigrade. The outer surface of the tank is black and heat transfer between the outer surface of the tank and surroundings is by natural convection and radiation. The convection heat transfer coefficient at the inner and outer surface of the tank are this. Okay. Now determine the rate of heat transfer to the iced water in the tank, and B, what is the amount of ice that melts during a 24-hour period. The heat is what? Okay. So should we discuss? So my dear friends, clearly you can see that it's a case of heat transfer from a sphere. This is the sphere and some thickness is given. For example, this is the concentric sphere whose some thickness is given. This is the thickness. This is the thickness it is given. Now here some iced water is kept. Iced water at 0 degree is kept over here. So here there will be heat transfer. Okay. Now this heat will be traveling through this thickness. From here it will be traveling, and finally it is exposed to the outer surroundings. So like this the heat will be going. So see, when iced water is there, ice is kept. So when ice will be losing heat, so ice will definitely melt. And that is the second part of the question, that how much ice is melting. How much ice is melting during a 24-hour period. So first of all we have to calculate what is the rate of heat transfer, and second part of the question is how much ice is melting, because it's when ice melt, when heat is transferred, ice will melt. Okay, so two parts of that there. So what I will do, I am first going to find the resistance, the internal thermal resistance, R1 or Ri, whatever you say. Then I will be finding the resistance due to this spherical tank. So that will be, let's say, Rs, R2 minus R1 by 4 pi k R1 R2. And finally I will be finding the outer surface resistance. I know both the temperatures. I know the outer and the inner temperature. I know the inner and the outer temperature. So basically I know all the things. I just have to calculate it. I just have to calculate it by the given data. Okay. So all the things I know. All the things I know. Cannot see the comments. Why?
It's like that only.
But I cannot see the comments. Chat is disconnected.
Wi-Fi problem, sir. Wi-Fi problem.
So it cannot be refreshed.
It connect. You don't have to make it.
Not connecting. For 10-15 minutes it is there.
Reconnect you.
Yes, anyone with the answer? Anyone with the answer? Anyone with the answer?
You kept the mic on, sir, while speaking with me.
ठीक, कोई बात नहीं.
It's coming, sir, actually.
I cannot see you.
Fine,
ठीक है. So what is the, for ice it is 1 by hi into A. So hi is given as 80 and what is the inner surface area of a sphere? The inner surface area will be 4 pi r square, or I can say pi di square. Surface area of a sphere is what? 4 pi r square, or I can say pi d square. So 1 by 80 and into pi, and what is the inner diameter? The inner diameter is given as how much? 5. Inner diameter is given as 5, so it will be pi into 5 square. 5 into pi square. So if you solve this, you will be getting 1 by ha value as 1 by ha value will be getting as 0. Now calculation I am not doing over here, I am simply writing the results. If you solve correctly, you will be getting the same answer. Okay. What will be this is the inner thermal resistance. What will be the outer thermal resistance? It will be 1 by H naught into outer area. So 1 by what is H naught? H naught is given as 10, and outer area will be pi d naught square. So it is given as 1 by H naught is 10 and pi into d naught. What will be d naught? What will be d naught? It is 5.03 meter. Why 5.03 meter? Because thickness is 1.5 centimeter. So outer diameter will be 2 into 1.5, that is 3 centimeter. So 5.03 square. So this is given as, when you solve this, you will be getting this value as 0.00126 degree centigrade per watt. And what will be the thermal resistance due to the material? So the formula is R2 minus R1 by 4 pi K R1 R2. So what is R2 minus R1? You know that it is 2.515 minus 2.5 that will be in meter, divided by 4 pi, and what is K value? K value is 15, 4 pi K, and R1 R2, that is 2.515 into 2.5. So all are in SI units only, so I am not writing it. It is in meter only that I have kept. And when you solve this, you will be getting as 0.000013 degree centigrade per watt. So all the thermal resistance I have calculated. So if I ask you what is the net or total thermal resistance, so it will be the inner one plus the outer one and plus the thermal resistance due to the material. So if you add all the things, you will be getting as 0.000981 degree centigrade per watt. You will be getting this R total. And finally, what is the steady state heat transfer? The steady state heat transfer will be delta T divided by R total. What is delta T? Delta T is the temperature difference, and that you know very well that it is 30 from the outside and 0 degree, divided by, when you put 0.00981 degree centigrade per watt. So this is degree centigrade per watt. So finally you will be getting answer as 30,581 watt. 30,581 watt. 30, so this is the rate of heat transfer. This is the rate of heat transfer that we will be getting. That is the rate of heat transfer. Now first part of the question is done, and second part of the question is that how much ice melts? What is the amount of ice that melts during a 24-hour period? In 24-hour period, how much ice is melting? And heat of fusion is given as this. That means for 1 kg, 333.7 kilojoule of heat is required. It is required. Okay. Okay. So my dear friends, this much of, or I can say that this is 30,581, it is joule per second. So in 1 second it is transferring this much of joule. In 1 second it is transferring this much of joule. So can you say he is asking in 24 hour. In 24 hour how many energy will be transferred? In 1 second he is transferring this much. So in 24 hour it will be 24 into 3600, that much of joule will be transferred. So I am directly writing in terms of kilojoule. So this much of kilojoule of heat is transferred. For 1 kg of ice melting, 333.7 kilojoule of latent heat is required. So how then this is the total amount of heat that is supplied. So finally what I can say, that what is the amount or mass of ice have melted. What is the amount or the mass of ice melted? So that is nothing but 2.642 into 10 to the power 6 kilojoule divided by 333.7 kilojoule per kg. Kilojoule, this is kilojoule and this is kilojoule per kg. So ultimately whatever answer I will be getting, it will be in kg only, and if you find that, that is 7918 kg. 7918 kg is the amount of ice that has melted. So finally we have solved this big question. Anyone got the answer? Anyone got the answer? Anyone got the answer? So Loki Christine, your answer was not correct. Why it was not correct? Yes. Gate aspirant, good evening. It was not correct. Why are you committing so many calculation errors? Why are you committing so many calculation errors? Why are you calculating?
Internet. Chat disconnected.
I told you that we are not able to see comment. थोड़ा दो बोल दीजिए बच्चों को. आपके लैपटॉप पे तो दिख रहा है, देखो 20.8 कुछ आंसर लिखा है इधर. तो वही तो नहीं दिखा ना मेरे. अच्छा अब दिख रहा है. हाँ कहाँ दिख रहा है? तो कुछ लिख रहा है चैट पे. नहीं. Come. My laptop में. लैपटॉप से देख लो. एसी बना दी कम. बट चार्जर Yes, just a minute. We'll be starting in 2 minutes. I'm just not able to see your comments. We'll be starting in 1 minute. I'm just not able to see your comments. Rakesh? Okay, so some chat problem was there. Now I am able to see your comments. No issues. So yes, Loki Christine, you are saying that I have calculated calculation error. Are you sure that you have not committed error? Are you sure that you have not committed calculation error? Tell me. Are you 100% sure? Chalo. So if that is correct, now let us move towards the next question. If that is correct, now let us move towards the next question. Okay, please read the question. Please read the question. Okay, okay, let's move ahead. Let's move ahead. Let's move ahead. Please read the question. This is the next question, my dear friends. This is the next question, and this is the question of fins. From fins, it is the question. I am giving you 2 to 3 minutes to think about the question. Please try. Please try. Please try this question. Should we discuss? Should we discuss? So what this question is saying? This question is saying that a hot surface at 100 degrees centigrade is to be cooled by attaching 3 centimeter long 0.25 centimeter diameter aluminium pin fins whose K value is also given with a center to center distance of 0.6 centimeter. So this is the center to center distance. Center to center distance is 0.6 centimeter. The temperature of the surrounding medium is 30 degrees centigrade. Okay, no issues. And the heat transfer coefficient on the surfaces is this much. Determine the rate of heat transfer from the surface for a 1 meter into 1 meter section of the plate. Determine the rate of heat transfer from the surface for a 1 meter into 1 meter section of the plate. Okay. So this is one of the best questions of fins that you will be coming across. This is one of the best questions, and I recommend that if you are able to understand this question, you will be very much confident, at least in this section which is known as fins. In this portion of fins, you will be very, very confident once you take up this question. Okay, so let us discuss. No issues. So my dear friends, first of all, you just see that from where he is asking the rate of heat transfer. From the entire surface, plate surface, he is asking you the rate of heat transfer. He is not only asking you through the fins, he is asking you from the entire plate. And your plate has some fin area and some not fin area. Is my fins on the entire plate? No. Some area is covered by fins. Yes. Some area is not covered by fins. So from fins also you need to find. From non-fin area you need to find. Number one. Number two. Temperature difference you know, that is not the issues. Temperature you know, that is not the issues. H value also you know, that is not the issue. So what is the issue? You need to know that how many, first of all, what is the area of one pin? What is the area of one pin? Number one. Number two, how many fins are there? In a area of 1 meter square, how many fins are there? That we don't know. So that also we need to find out. Right? So many complexities are there over here, and let us solve one by one. You just focus on how I am proceeding. Okay? So I hope you have taken the picture of this question, and then I'll be focusing on solving. Question, is it clear to you? Is the question and the explanation clear? Is the question and explanation clear? Okay, so I hope you have taken the picture with the important data, and now I am focusing on solving. So first of all, you know that the M value that we find out in any fin question, the first thing that we found out is the M value, HP by KAC. HP by KAC. So what is H value? So H value is given, first of all, okay, HP, P is what? Pi D. Cross section, ये cross section का होता है. This is for cross section. K. And what is AC? Cross section, pi by 4 D square. So when you simplify this, you will be getting 4H by KD. 4H by KD. So what is H? H value is 35. H value is 35. And what is K? K value is 237. And what is D value? D value is 0.0025. I have to keep in meter. Why? Because all, the SI unit we are following. So now we have to M value. So M value will come out to be 15.37. 15.37 meter inverse. Okay. Now my dear friends, what I'll do, I'll first find how many fins are there. Now try to understand this concept once, that suppose this is the square plate. And there are fins over here. Let's say this is the fins over here. Now we need to calculate one fin area. We can very easily calculate. I need to calculate what is the total number of fins. And he has given that what is the center to center distance. The center to center distance is given as 0.6 centimeter. So let's say this is one center, this is one center. So this center to center distance is given as 0.6 centimeter. 0.6 centimeter. So my question to you is, I need to find the number of fins. So number of fins, you would generally, what you would say, that sir, total area of the plate, that is 1 meter into 1 meter, divided by area of one fin. And you will get the total number of fins. But tell me one thing, is your fins occupying the entire flat plate? Is your fin occupying the entire flat plate? No, there are some distance. So you cannot apply this formula. there is some distance between the fin. You cannot apply this formula. So what you have to find? You have to see that, let's say this is a section of 4 fins that I am taking. So in a square of, this is 0.6 and this is 0.6 centimeter. So in a square section of 0.6, how many effective fins are there? This is, let's say I am considering a square section of 0.6 into 0.6. So in a square section of 0.6 into 0.6, how many effective fins are there? How many effective fins are there? My dear friends, if you see this figure, if you have understood this figure, you will be getting to know that in a section of 0.6 by 0.6, there is a total of 1 fin that is lying. So your total square section is 1 into 1, and 0.6 centimeter area, 0.6 into 0.6 centimeter square area mein you have 1 fin. So now total how many fins will be there? Total how many fins will be there? Total, the number of fins will be 1 meter square by 0.006 into 0.006. That will give you the total number of fins. And if you solve this, you will be getting 27,777 fins. 27,777 fins. Is this clear or not? Is this clear or not? If this is clear, we can move to solve the next question. Now, next part of the problem. Now, my dear friends, what is the total area of the fin? So, obviously, you will say that, sir, the total number of fins multiply by area of 1 fin. Area of 1 fin. So, what is the area of 1 fin? Obviously, it is pi dl plus the cross section pi by 4 d square. Okay. So 27. What is pi dl? Now pi dl. So this is for 1 fin. This is for 1 fin. This is for 1 fin. So 0.0025 pi d L. L is what? 3 centimeter. So converting into meter plus pi by 4. What is d square? It is 0.0025 and it is a square. So if you find this answer, it is coming out to be 6.68 meter square. So this is the area of the total fin. Area of the total fin. So my question to you is heat transfer taking place from only fin? No. From the non-fin area, heat transfer is taking place. So what is the non-fin or unfinned area? What is the unfinned area? So total, what is the unfinned area? What is the unfinned area? So don't subtract 1 minus directly this. Don't subtract 1 minus this much. This is the, heat transfer area, the area which is available for heat transfer from the total fin. But if I have to find the unfinned area from the square, so what I would do, let's say this is the square plate. So let's say this one. So this much is covering. Let's say this much is there, this much is there, this much is there, this much is there. So for this, what would I find the unfinned area? I would simply write 1, that is the total square plate, minus 4 times. And what is this circle area? It is pi by 4 into d square. Yes or no? So 1 minus 20. Now how many fins were there over here? 27 into what is the area? Cross section area pi by 4 d into what is the cross section area? The cross section area is 0.0025 square. So when you solve this, you will be getting 0.86 meter square. So this is the unfinned area and this is the finned area. So first we have to find the area of heat transfer from the finned area, and this, then I will be finding the heat transfer from the unfinned area. Okay. Now my question to you is how to find the everything. The basics we have completed. Now my question is how to find the heat transfer. See, there is one way that whether you can we have read the three cases of heat transfer. So either you can consider it to be the case of infinite long fin, then but it can also be a case of adiabatic fin tip, and it can also be the third case. So you will be thinking that which one to apply. So we'll not go by that method. We will not go by that method. Rather, we will opt a different method. What is the different method? We will find the heat transfer from the fin. How? By multiplying by efficiency of the fin into the maximum heat transfer from the fin. This is also one way. Don't forget, this is also one way. And see how we are finding. So Q max, this is the Q max. This is the Q maximum from the fin, and this is the efficiency of the fin. So efficiency, let's say I am assuming it to be an infinitely long fin. I am assuming to be infinitely long fin. So efficiency क्या होगा? Tan H ml by ml. Tan H ml by ml. So what is tan hyperbolic m? What is so we calculated in the beginning, it was 15.37 into what is the length? The length is 0.03 meter, and divided by what is m, it is 15.37 into 0.03. So if you calculate this, the efficiency will come out to be 0.935. This is the efficiency. Now what is the Q max? Q max, what is the concept of Q max? That when the entire fin temperature is at the base temperature, and then calculate what is the amount of heat transfer. So that is nothing but HA, the entire is at base temperature, minus T infinite. Okay. Okay. So directly, should I write it directly? What is the Q from the fin? What is the heat transfer from the fin area? So efficiency is 0.935. And what is H value? H value is 35. And what is A? Now area I am not taking for one fin. The total 27,777 fins. That came out to be how much? 6.68. So 6.68 into what is TB? When I told you, when the entire fin surface is assumed to be base temperature. So 100 minus T infinite. T infinite is what? 30. T infinite is 30. Now what is the Q fin? Q fin is 15,300 watt. 15,300 watt. Now this is the Q fin. Is this your answer? My question is this your answer? Will this become your answer? No. No one is replying anything. Will this become your answer? No. First, then I have to find what is the Q from unfinned. Unfinned कैसे होगा? Unfinned. What will be Q unfinned? So H, area of unfinned. And which part? The part which is not, where fin is not there. Definitely it is at the base temperature. Yes or no? Okay. So what is H? H is nothing but, H is what? H is 35 given. Unfinned area we have found out. Unfinned area is 0.86. Unfinned area is 0.86. And what is the base temperature? Base temperature is 100 minus 30. Base temperature is 100 minus 30. 100 minus 30. So if you solve this, it will be 2107 watt. 2107 watt. So now I can say what is the total heat? Total heat is nothing but Q from fin plus Q from unfinned area. So what is Q of fin? Q of fin came out to be 15300. 15300 plus 2107 is equal to, what is the answer? You will get us 17.4 kilowatt. 17.4 kilowatt. 17.4 kilowatt. 17.4 kilowatt. Okay. And my dear friends, this question is done. Question is done. Loki Christine, where are you? Loki Christine, where are you? I am not seeing any answers from your end. I'm not seeing any answer from your end. So I told you that this is one of the best question of fins that you will come across, and if this is clear, my dear friends, you will be able to tackle any fin question. Now, my dear friends, the question is done. Whatever he was asking, the question is done. Determine the rate of heat transfer from. Determine the rate of heat transfer. The question is already done. Now, now, what if he asks what is the effectiveness? I have not asked over here, but this can be a very beautiful MSQ question. What if he told you that what is the effectiveness of the fin? What is the effectiveness? So what would you have done? Q with fin divided by Q without fin. This is not the question. Question is already done. But what if we ask you what is the effectiveness? So effectiveness Q with fin. You already know that is 17,000. After fin, what is the heat transfer? After fin, the heat transfer is 17,400. See, after fin, what is the heat transfer? And when fin was not there, that means only square plate was there. So simply you will find HA delta T. So what is HA delta T? What is HA delta T? HA delta T is nothing but 35, and area of the plate is 1 meter square, and delta T is 100 minus 30. So if you solve this, you would have got some 2450. Anyway, the final answer would have been 7.10. 7.10 is the effectiveness. That means effectiveness is 7.10. This is not asked, but this could have been asked. So my dear friends, I hope that this big fin question is clear to all. Is it clear, my dear friends? Is it clear? ये सबको clear है? So yes, the name of the session is Gate Booster. Session. If you don't do such tough questions, then you will not feel that much of confidence. So I hope that this question is clear. We have done a very good question based on heat transfer, right? So without wasting any time, I am simply going to the next question. My dear friends. Yes, here is the question. Now we have done enough questions from conduction. Now it's time to change the chapter. Yes, Pragyavit Tripathi, where are you? You are very irregular. Please stay connected. I am seeing no answers from your side. Yes, please read the question, please. So I'm giving you 2 minutes to read and think whatever you can, Yes, now solve this question. Yes, now solve this question. So, got any clue? Got any clue how to solve this question? Okay, so let me quickly now help you solve the question. What the question is saying? A metallic airfoil of elliptical cross section has a mass of 50 kg, surface area of 12 meter square, and a specific heat of 0.5 kilojoule per kg Kelvin. The airfoil is subjected to airflow at 1 atm, atmospheric pressure 25 degrees centigrade, and 8 meters per second along its 3 meter long side. Okay. The average temperature of the airfoil is observed to drop from 160 to 150 degrees centigrade within 2 minutes of cooling. Okay. Assuming the surface temperature of the airfoil to be equal to its average temperature, and using, now this is the most important word, or words in this question. This is only is going to guide you that what you should apply in this question. Using momentum heat transfer analogy, determine the average friction coefficient of the airfoil surface and the properties of air at 25 degrees centigrade and 1 atm is given to you. So this is going to give you the idea that momentum heat transfer analogy you have to apply. My dear friends, let me tell you one thing, my dear friends. All these questions, you are finding it to be difficult, or it seems difficult to you, but none of the, apart from 2 to 3 questions, none of the question solution will be more than 5 to 6 lines. I tell you, none of the question solution will be more than 5 to 6 lines. And after reading, you will think that it is a very difficult question. So that is the beauty of the questions that I have taken. That is the beauty of the questions. Proper gate level, tough 2 marks question. Based on that only I have taken all the questions. Okay. So coming back, what is momentum heat transfer analogy? What is momentum heat transfer analogy? What is momentum heat transfer analogy? Cfx, the final result, Cfx by 2, Stanton number into Prandtl number to the power 2 by 3. If someone asks you what is the momentum heat transfer analogy, that is the Reynolds-Colburn theory. Reynolds-Colburn theory, that is the connecting link between fluid mechanics and heat transfer. What equation would you write? This is the equation that I would write. Okay. So he is asking what is Cfx. Fine. Left hand side he is asking. Prandtl number I already have, isn't it? Prandtl number already I have 0.7296. Very good. I only need to find what is Stanton number. What is Stanton number? Rho VCP. Rho VCP. Rho VCP by H. Rho VCP by H. Rho VCP by H is the Stanton number. Rho is also given, V is also given, CP is also given. Everything is given. Rho V, CP, rho, CP, and V is also given, I think. Velocity 8 meter per second, 8 meter per second. Everything is given. Everything is given. Rho VCP by H, everything is given, but except one thing, and that is your H value. H value is not given. H value is not given. So my dear friends, now you have to think that how should we find the H value? If you find the H value, it is not more than 10 seconds question, but how to find the H value? So first, my dear friends, again I will take you to the question. This airfoil mass is given, Cp is given, and temperature drop is given from 160 to 150 within 2 minutes of time. So using all this data, can I find the heat transfer from the airfoil? From the airfoil? Yes. So heat transfer from the airfoil. M Cp dt, joule by time. So I will get in what? Okay. So what is the with the data? If you put all this, it will be 50. CP is 500. Now why I'm not writing the units? I'm not writing the units because I'm already writing in SI unit. Okay, 500. If you find the temperature drop, it was 160 minus 150. Okay, divided by T. Time. 2 minutes. So 2 into 60 seconds. 2 into 60 seconds. If you find this, you will be getting 2083 watt. 2083 watt. I have already got the Q airfoil. Now also it is equal to HA delta T. Also it is equal to HA delta T, yes or no? And here H is lying. Very good. So Q is equal to HA delta T. Okay, I need to find H value. So Q by H into delta T. Very good. Q value already found out, 2083. 2083. Okay, what is the area? Has he given area? Wait, 12 meter per second. It is 12 meter per second. And what is del T? Now del T is the heat transfer of the foil to the atmosphere. So atmosphere to already 25 is given. But foil temperature, what will you take? Average temperature you need to take. Average temperature. What is the average temperature? 160 to 150. What is the average temperature? 155. So 155 minus 25. So my dear friends, if you find this, you will be getting H value as 1.335 watt per meter square degree centigrade. So my dear friends, H value is known. Now my dear friends, everything is known. Now my job is done. H value I have told you, rho V Cp, everything you know, Prandtl number you know, and what is finally CFX. So I am simply substituting everything in that formula. Prandtl number to the power 2 by 3 by rho V Cp. So 2H 1.335, Prandtl number value already given, that is 0.7296 to the power 2 by 3 divided by rho value is 1.184, and what is V? V is 8 meter per second, and Cp value already given. One in SI unit I have put in SI unit, and my dear friends, when you solve this, you will be getting your answer as 0.000227. This is the skin transfer coefficient. Tell me, no, GATE aspirant, please check your calculation. This is the final answer. Tell me, is the question clear? Tell me. Is the question clear? As I said, not more than 5 to 6 lines. Are these questions. ये clear है? Should we move ahead? Should we move ahead? Should we move ahead? Okay, Shreya. Okay, yes, correct. Shreya, yes. Shreya, yes, absolutely correct. It is reverse. H by rho V Cp, correct. Good point out. Shreya, yes, correct. H by rho V Cp, correct. Now is it okay? I have substituted, I think I have substituted correctly, but now it is okay. Yes, correct. In the main formula, I have written in the reverse way, but I think in the while substituting, I have substituted it correctly. Now is it okay? Now is it fine? Should we proceed? Should we proceed? Should we proceed? Ready for the next question? Ready for the next question? Okay, okay. So we are not wasting even a single time. We are not wasting even a single time. And my dear friend, this is the next question for you. This is the next question for you without wasting any time. We are not going to waste a single time. This is the next question. Please hurry up. Please hurry up. We have to cover a lot of questions today. So this is a very standard question that I have taken from external forced flow through the plates. External forced flow through the plates. This is a very standard question that I have taken, and I expect all of you to get the answer. I expect all of you to get the answer. Loki Christine, Pragya Tripathi, are you there? Because I am not seeing any answers from you guys. So what is the question? The question is, engine oil at 80 degrees centigrade flows over a 6-meter long flat plate whose temperature is 30 degrees centigrade. Okay. With a velocity of this much. Determine the total, determine the rate of heat transfer over the entire plate per unit width. Per unit width. Per unit width. And the properties are given. The properties of the engine oil at the film temperature is given. Properties of the engine oil at the film temperature is given to you. Okay. Okay. Should we start? Should we start? Yes. As I said, it's a very standard question. I expect all of you to get the answer. So now let us solve. My dear friends, what is the relation? I'll tell you what is the sequence. The sequence is very simple. First, I have to find the Reynolds number. If I will find whether it is laminar or turbulent. If it is laminar, I am going to use one relation. If it is turbulent, I am going to use another relation. Let's say it is laminar. One relation, Nusselt number, Reynolds Prandtl given. Nusselt number I'll get. If Nusselt number I'll get H. Once you get H, you get the rate of heat transfer. This is a very standard question in your entire convection chapter. In your entire convection chapter, the one thing that you need to focus on is on getting how H. If I get the value of H, area I know, temperature difference they already will give us, I will get the answer. In the last question also, I only needed H. Stanton number 1, I only needed H. So in your entire convection, your only focus will be to get H. Once you get H, your job is done. Here also the same thing I am going to do. So what is the first step? The first step is I will be finding Reynolds number. What is Reynolds number? Rho mu. What is Reynolds number? So rho VL by mu. Rho VL by mu. Rho VL by mu. So mu by rho I can write as VL by nu because nu value is given. Okay, V is 3 meter per second, L is 6 meter, and what is nu? Nu value is 123 into 10 to the power minus 6. Okay, 123 into 10 to the power minus 6. When you solve this, you know the Reynolds number I will get as 1.46 into 10 to the power 5. 1.46 into 10 to the power 5. Now my dear friends, tell me, What is the flow? Is the flow laminar or is the flow turbulent? Definitely the flow is laminar. Why the flow is laminar? Because the critical, it is less than the Reynolds number critical. What is the critical? Critical is 5 into 10 to the power 5 is the critical. After that only it will be turbulent. But it is less than that, so it is laminar. If it is laminar, you know what is the relation? Nusselt number across the entire plate 0.664 into Reynolds number for the entire plate to the power 1 by 2 and Prandtl number to the power 1 by 3. Is the relation I have written correct? Is the relation that I have written is correct? Yes, absolutely correct. Now my dear friends, it is 0.664. What is the Reynolds number? 1.46 into 10 to the power 5 to the power 0.5. And what is the Prandtl number? Prandtl number they have already given. Prandtl number they have already given. What is the Prandtl number? 1505. 1505. Okay. 1505 to the power 1 by 3. My dear friends, if you calculate the Nusselt number, if you solve this, you will be getting 2908. 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 Okay. How to get H? You know, Nusselt number is equal to HL by K. HL by K. HL by K. Okay. H equal to Nusselt number K by L. So Nusselt number is what? Nusselt number is 2908. It is 2908. 2908. What is the K value? K value 0.141. 0.141. 0.141. 0. See, here is the K value. Here is the K value. Here is the K value. See over here. See over here. See over here. Okay. 0.141. And what is the L? L is 6. L is 6. If you solve this, you will be getting 68.3 with all the standard units watt per meter square degree centigrade. If I know H, very easily Q value I will be getting HA delta T. So H value is 68.3. And what is the area? Area is 6 into per unit width is saying. So 1 I have taken and delta T. What is the delta T? What is the delta T? 80 minus 30. 80 is the surface, 30 is the environment. If you solve this, you will be getting 20.5 kilowatt as the answer. 20.5 kilowatt as the answer. 21. No, GATE aspirant, all the answers you are getting wrong only. No, Shreya, your answer is incorrect. Why it is not matching? Why it is not matching? Or have I calculated any calculation error? Why it is not matching? Or have I done any calculation error? Have I done any calculation error? Have I done? No, it is possible. I can also do calculation error. That is not the big deal. Okay. Fine. So should we proceed? Should we proceed for the next question? I know how much precious is your time. I know how much precious is your time at this instant. So, keeping that in mind only, in less time, how you can revise the entire heat transfer with all the best questions, that is my intention over here. Right? So, my dear friends, without wasting any single time, let us move to the next question, my dear friends. Please. This is the next question. So another one of the best questions that you will come across of pipe flow. One of the best questions that you will come across of, you know, heat transfer. Should we discuss? Okay, so what he's saying, let us discuss. Okay. He's saying that combustion gases passing through a 3 centimeter, internal diameter circular tube are used to vaporize wastewater at atmospheric pressure. Okay. Hot gases enter the tube at 115 kilopascal and 250 degrees centigrade at a mean velocity of 5 meter per second and leave at 150 degrees centigrade. If the average heat transfer coefficient is 120 watt per meter square per degree centigrade and the inner surface temperature of the tube is 110 degrees centigrade, so determine what is the tube length, and the rate, second, B, the rate of evaporation of water. So it is one of the best questions that you will come across. It is one of the best questions that you will come across. Okay. Now, my dear friends, see one thing. Wastewater is at one temperature, that is 110 degrees centigrade. Try to understand that when combustion gases are flowing from here, they are at a temperature at the entry, they are at a temperature of 250 degrees centigrade. And when they are exiting, it is at 150 degrees centigrade. And in this pipe, there will be tubes. There will be tubes, something like this. Or it can be, it can be something like this also. That is not the issue. Okay. But they are at a constant temperature. Why? Because tube may water is flowing and that tube temperature is 110 degrees centigrade. That is constant. Now he is saying that determine the tube length. My dear friends, try to see one thing. Your tube will be something like this. Entire. In any way the tube can be, but how do we get the tube length? Tube length we will get from pi dl only. Length is given, length he is asking, right? Diameter is given 3 centimeter. So L we can find out, and for that we need to find out A. We need to find out what is A value, that means area value. Okay. Again, if you try to go in a reverse way. I am not going from the top to bottom or starting to end. I am trying to guess that what should I do first. I am just doing permutation combination. I am just trying to guess that how should I proceed for this question. That I am thinking. So average heat transfer coefficient he has given. Average heat transfer coefficient, definitely HA delta T concept will be used. See how I am trying to guess, please. So H area I can get from here. Okay, H he has already given, no issues, my dear friends. Now delta T. See, my dear friends, as it is moving, as the hot gases are moving from one end to other end, in the tube wastewater is there and it is at a constant temperature. That means at every instance the temperature difference is changing. At every instance the temperature difference is changing, and whenever it happens, that means it is a heat exchanger. It is a heat exchanger where at every distance, every length, the temperature difference is changing. And if we have to take a certain delta T, if we have to take one single delta T, that means I need to use the concept of LMTD, logarithmic mean temperature difference. Okay, so my dear friends, how to get LMTD? You will say that, sir, for LMTD we need 4 temperature, but my dear friends, 2 temperature I already know, and the third one, the water is constant at 110. That means it's a case of evaporation condensation, and you know that whether it is counter flow and whether it is parallel flow, we have the same formula. Yes or no? So LMTD we will be able to get. No issues with that. Very good. But again, how to calculate Q? That is another thing. Delta T, matlab I can write, sir, this is nothing but LMTD. LMTD se, it's a heat exchanger, so LMTD se mil jayega, no issues. But how to calculate Q? Again, my dear friends, you need to see. You need to see that how any information about the hot gases. Any information about the hot gases that he has given? Any information about the hot gases that he has given? Okay. MCP delta T. Okay. So how much heat is transferred from the hot gases? Let me write the hot gases. Okay. So it's a very, very good question, my dear friends. Very, very good question. See, M dot, since it is flowing, dot Cp delta T. So M, Cp value do I know? Cp value 1023. Cp value do I know? Cp value do I know? 1023. 1023. Okay, 1023. So Cp value I know, 1023. Delta T do I know? Delta T 250 minus 150. 250 minus 150. But do I know mass? No, I don't know mass. Then how to calculate mass? Now he has given some extra information. Some extra information he has given for mass. Some extra information he has given for mass. Rho into Q. Rho into area into velocity. So what is rho? Density has he given? No, density he has not given. Area do I know? Pi by 4 d square. Area I can find pi by 4 into d square. See the beauty of the question. Pi by 4 d square. And velocity has he given? I think he has given the velocity. I think it is 5 meter per second. 5 meter per second. But I don't know. I don't know what is rho. Again, rho you can find. It's air. Air, can I treat it? Air, can I treat it as an air? Can I treat it as an ideal gas? Okay. P equal to rho RT. P equal to rho RT. Rho RT. Rho equal to P by RT. P by RT. Okay. What is P? 115 kPa. 115 kPa. What is P? 115 kPa. What is R? 0.287. 0.287. And what is temperature? He has told that it is entering at, how much it is entering? It is entering at how much? 250. So should I put 250? No, it should be in Kelvin. So 250 plus 273. Okay. If you solve this, the rho value will come out to be 0.7662 kg per meter cube. See, rho value I have got. When I have got rho value, can I calculate mass? So 0.7662 rho pi by 4 into, what is the d square? What is the d square? 0.03 square. And what is the v? V is 5. So if you find m dot, it will be 0.0027 kg per second. 0.02 cent kg per second. And then when you substitute over here, see how reverse I am doing. When you substitute over here, then you get the heat transfer as 276.9 watt. See how reverse I am trying to do. How in a reverse way we are trying to do. This is the Q. My dear friends. Now go back. I know Q. I know area. I need to find delta T. Oh my God. What a question this is. Okay. So delta T is equal to, assuming counter flow or parallel flow, you will get the same answer. Inlet, exit by exit. So once is 250, it is cooling down to 150, and it is 1110 and it is 1110, the tube temperature. Okay, no issues. So delta Ti is 250 minus 110, 140, and delta Ta is 150 minus 110. So it is 40 and 140. So what is delta T? LMTD is delta Ti 140 minus 40 divided by ln 140 by 40. When you solve this, you 79.82 degrees centigrade. LMTD we have got. LMTD I will put it over here. H I know 120. Q I know, so I'll get area. Very good. Now we can see the end. Of the question. Okay. So Q is equal to HA delta T of LMTD. Okay. What is Q? Q already we have found out. 276.9. H value 120. Area I don't know. Just now LMTD 79.82. From here, what is the area? From here, if you find, the area will be 0.02891 meter square. Now the total area of heat transfer I know, and he's asking the tube length pi dl. So area is equal to, now I know all the things. Now I can see pi d is 0.03 L. So my dear friends, L value you will get to be 30.7 centimeter. Is it clear, my dear friends? Is it clear? Tell me. Acha, is the question done? I think he is asking some more. Acha, rate of evaporation of water. Oh my God, another hidden question is there. What is the rate of evaporation? What is the rate of evaporation? That means, I think it's asking mass flow rate. No issues. Mass flow rate is asking. So do we know the total heat transfer? 276.9. Okay, we know the total heat transfer. No issues. So Q dot is equal to mass into HFG. That is the latent heat of fusion. So I think he's asking kg per second. So Q dot I know it is in terms of kilowatt, it will be 2769 in terms of kilowatt is equal to m dot. And what is HFG? Anyone? What is HFG? HFG he has given as 2257 kg per kilojoule per kg. 2257 into 2257. So when you calculate m dot, it will be 0.2769 divided by 2257. So whatever answer you will get, it will be in kg per second. Is it clear, my dear friends? Is it clear? Are you able to understand the questions? I know it's a bit on the tougher side, but are you able to understand the question, my dear friends? I know it is on the tougher side, but are you able to understand the questions? Please let me know. Please tell me. Are you able to understand the questions? See, if you don't respond, then if you feel it is helpful, then only I'll be coming up with more sessions. But if you think that you're not able to solve or you're not able to understand, then I should stop after this session itself. Okay. So my dear friends, now let us proceed. We'll come to the, since we have already done one question from LMTD, heat exchanger, so we will come back to it after some time. But now let us do one question from convection, free convection. Now let us do one question from free convection. Please. Now let us do one question for free convection. Please read the question. So in this question, he is asking the rate of heat transfer in three cases. In three cases he is asking. The figure is also given to you. The figure is also given to you. The figure is also given to you. So what is the question? What is the question? The question is, consider a 0.6 meter into 0.6 meter thin square plate in a room at 30 degrees centigrade. Okay, 30 degrees centigrade square plate. One side of the plate is maintained at a temperature of 90 degrees centigrade. Very good. One side of the plate 90. While the other side is insulated as shown in figure. Clearly you can see. Determine the rate of heat transfer from the plate by natural convection when A, it is vertical, B, it is horizontal with hot surface facing up, and C, when it is horizontal, when hot surface facing down. My dear friends, you will get to know many things in this question. See, the only thing is that one thing you should note over here, that over here and the product of Reynolds number and Prandtl number will not come into picture. Here the product of Grashoff's number and Prandtl number will come into picture. Grashoff into Prandtl is known as Rayleigh number. So what I have done, I have directly given the Nusselt number and Rayleigh number relation to you. So you know that you have to calculate Rayleigh number and then you have to use the Nusselt number relationship. From there you will be getting H value. Once you get the H value, you will be calculating the rate of heat transfer. That is this sequence. See, one thing you remember, whenever we need to calculate the amount of heat transfer, ultimately area we know, delta T also we know. It comes down to getting or determining the value of H. Once you get the value of H, you will be very easily solving the question. But H value you need. And for H value only, you have so many relations to, that is the, I can say that the 60% of the chapter tells you the relation between how to get finally the H value. That's why so many relationships are there. So ultimately H value I need, that's why so many relationships are there. Once I get the H value, I'll be getting to know the, I'll be getting to know the, the heat transfer. Okay, so I think the chronology you have figured it out. So let me find out first. So in first case, in A, I am, by the way, Nusselt number, Rayleigh number, the same relationship you will not use everywhere. This is for A, then the second is for B case, and third is for, it is for the C case. Okay. Now my dear friends, straight away let us proceed. I'm finding, by the way, you know that when I write the Grashof number formula, there a term of characteristic length comes into picture. The characteristic length changes in every question, at least in the first two. In the first one, characteristic length is nothing but the length itself. Characteristic length is nothing but the height of the plate itself. But in the second case, it is not the height, it is but area by perimeter. Area by perimeter. Also in the last case also, it will be the same. Okay. This is where you need to focus. This is where you will get something extra of these sessions. So what is the characteristic length over here? It is the height, and it is nothing but 0.6 meter. Okay. So what is Rayleigh number? Rayleigh number is nothing but Grashof's into Prandtl number. Grashof's into Prandtl number. Okay. What is Grashof number? G beta delta T LC cube by nu square into Prandtl number. What is G? Now I am putting all the values. 9.81. What is beta? Already he has given that beta is nothing but 1 by TF, that is the mean film temperature. And what is TF? TF is nothing but, in terms of Kelvin we have to substitute. In terms of Kelvin we have to substitute. In terms of Kelvin we have to substitute. 60 degrees centigrade plus 273, it will be 333 Kelvin. Okay. So beta is nothing but 1 by 333 Kelvin into, what is the delta T? Delta T is nothing but 90 minus 30. Okay. What is LC cube? It is nothing but the height, so 0.6 cube divided by, what is nu square? Nu value have they given? Nu value, yes, nu value have they given 1.896 into 10 to the minus 5. 1.896 into 10 to the power minus 5. And Prandtl number, what is the Prandtl number? Have they given? Have they given the Prandtl number? 0.7202. 0.7202. 0.7202. Once you substitute over here, so Rayleigh number will come out to be, the Rayleigh number will come out to be 7.656 into 10 to the power 8. This is the Rayleigh number. My dear friends, I'll tell you, the relationships they will give it to you. No need to worry about it. Relationships, they will give it to you. You just have to use it. Okay. So Rayleigh number they have given. It is done. Okay. Rayleigh number it is found. Rayleigh number it is done. Rayleigh number it is found. Rayleigh number it is found. Okay. So what is the relation that they have given? The relationship that they have given is Nusselt number is equal to 0.59 Rayleigh number to the power 1 by 4. So 0.59 into, what is the Rayleigh number? Rayleigh number is 7.565 into 10 to the power 8. If you solve this, you will be getting close to 98.14. If you solve this, you will be getting close to 98.14. Okay, this is the Nusselt number. Now you know the sequence. I need to find H, HLC by K. So Nu into K by L. Okay. So Nu, it is first of all 98.14, and what is K? K value they have given is so K value they have given is 0.02808. And what is L? It is 6 meter. So then you will be calculating the H value. So H value will be getting, once you get the H value, what is area? AS is L square, flat plate hai, L square 0.6 square. You know H. What is Q? Q is HAS delta T. So you know H, you know AS and delta T is 90 minus 30. So whatever you get the answer, I'm not solving over here completely, but once the method is clear, then I will, I'll move ahead. So this is the ACE area. This is the ACE. Or this is the, the heat transfer that we are looking. Is it clear? Is it clear? Is it clear? Okay. My dear friends, what is the difference between the first part and the second part? All the method is same. What is the difference then? What is the difference from in the first part and the second part? What is the difference? See, one part I have already done. Now second and third you have to do. But how to do? In the second part, my dear friends, the second part will vary how? How the second part will vary? In the B part, your characteristic, everything that we have done, everything remains the same. But where it actually varies, it will vary in the characteristic length. It is area by perimeter. Area of the surface is L square. Perimeter is 4L, so ultimately it is L by 4. Only remember that when it's a horizontal plate, the characteristic length formula becomes AC by L square. AC by L square. LC by L square. Okay. So L is what? L is what is the L? Anyone? L is 0.6 meter and 0.6 meter by 4. So you will get the characteristic length, and rest all the things are same. All the things are same. All the things are same. Rest everything remains the same. Everything remains the same. Everything. See, but one thing, my dear friends, one thing you have to understand, that I have not used the same Nusselt number relationship. I have changed the Nusselt number relationship for B, and I have changed the Nusselt number relationship for C. So Nusselt number relationships you have to check, and I'll tell you, they will give you in the examination mostly. Okay? So only the common ones you memorize. Rest they will give you in the in the examination. They will give you the Nusselt number relationship. So is it clear? Acha. By the way, third case में characteristic length formula. Second case is also horizontal. Third case is also horizontal. So will it be same? Yes, definitely yes. No issues. Once you know the characteristic length, what is the sequence? What is the sequence? Once I know the characteristic length, I'll be finding Rayleigh number G beta delta T LC cube by nu square. Rayleigh number आ गया. Rayleigh number से Nusselt number relationship they already have given. This is the Nusselt number relationship. वहाँ से H आएगा. H after that HA delta T, area will the same. Area will be the same. Delta T will be same. One thing are you observing? Over here in the first case it is 0.59 factor. In the second case it is 0.54. And in the third case it is 0.27. Why a sudden drop in the third case? I can clearly see if Nusselt number is more, area H will be more, so area heat transfer will be more. So definitely I can sense that the heat transfer I will be getting from the last case is slightly lower than the first two cases. Can anyone guess why it is so? It is because in the third case the hotter surface plate you are kept in the downward direction facing the floor. So most of the heat is trapped due to the enclosure. Where it will go? If it is trapped, then will there be sufficient heat transfer? Definitely not. That is why most of the heat will be trapped and the heat transfer area that you will be getting is low. That's why you can see the reduction in the third case. Okay. So my dear friends, I expect everyone to solve these two and tell me the answer in the comment section. Not now. Not now. After the session is over. Right? After the session is over. So is it clear? Is it clear? So one very good question on convection we have taken. One very good question on convection we have taken. Is it clear? Is it clear? Should we move? Should we move? So if this is done, if this is done, let us move towards the next question, my dear friends. Let us move towards the next question, my dear friends. Please, one of the another beautiful questions, one of the another best questions on convection. Please. Have you read? Should we discuss? Okay. So my dear friends, what this question is saying? He is saying that a 6-meter long section of an 8 centimeter diameter horizontal hot water pipe shown passes through a large room whose temperature is 20 degrees centigrade. So this is the temperature of the room, some outside ambient temperature. If the outer surface temperature of the pipe is 70 degrees centigrade, okay, determine what is the rate of heat loss from the pipe by natural convection. Oh my god. So when you see the question, you will feel that it is a question of forced convection, some forced convection, because we generally study internal flow pipe forced convection, fine, but it is not so. It is asking you what is the heat transfer by natural convection. And that is why he has given all the properties of air. This is the mean film temperature, all these things they have given. K value they have given, nu value they have given, Prandtl number, beta. So all the things which is required for for your free convection they have given. And my dear friends, as I said, Nusselt number and Rayleigh number relationship. See the relationship that they have given. See the relationship that they have given. It looks like a very tricky relationship that they have given. Anyway, but our approach should be the same. Our approach will be the same. Whatever the chronology we have in our mind, that is going to stay the same. Okay. So what is the first step, my dear friends? Okay. So what is the first step? So first step is nothing but the Grashoff's number. Acha, before Grashoff number also, see in free convection, we first find characteristic length. What is the characteristic length? Characteristic length is nothing but the diameter over in this case. And what is the diameter that they have given? The diameter is 8 centimeter. 0.08 meter they have given. Okay, LC okay. Now what is Grashoff number? Grashoff number is G beta delta T LC cube divided by nu square. So all the data they have given, and I have to simply put over here. And by the way, I should directly find the Rayleigh number instead. I should directly find the Rayleigh number. So if I find Rayleigh, it means this into Prandtl number also we have to do. Okay. G is 9.81. What is beta value? Beta value is, they have given over here 1 by 318. 1 by 318. What is delta T? Delta T is nothing but, see, when hot water is going through there, from here heat is transferring, heat is supplied from the outer surface to the surrounding. So what is the heat transfer? What is the temperature difference? 70 minus 20. G beta delta T. LC cube. What is LC? 0.08. 0.08 cube divided by nu. What is nu? Nu he has given as 1.749 into 10 to the minus 5. So if you calculate this, you will be getting, by the way, Prandtl number I have missed. Prandtl number, it is given as 0.7241. So when you calculate Rayleigh number, you will get as 1. This is the Rayleigh number. This is the Rayleigh number. Once you get the Rayleigh number, you will substitute over here. Prandtl number you will substitute over here, and you get the Nusselt number. So my dear friends, I am writing the Nusselt number. So I am using that relationship. So I'm directly writing because I've calculated already. So I'm writing what you will get after substituting. In that big relationship. So no need to afraid, it is just mathematical calculation only. This to the power whole square. So you'll get the value of 17.40. You will get the value 17. And you know the after drills. What are the after drills? Once you get Nusselt, I have to write HLC by K. H value is what I basically need to calculate. HLC, LC. LC is nothing but diameter. So it is, K value is this. Nusselt number is 17.40, and what is LC is 0.08 meter. That is the diameter. So what is the H value that we are getting? So this is the H value. And now what he is asking? Rate of heat transfer. Okay. So how to get the area? Area of heat transfer is not given. So my dear friends, see one thing. From what area the heat transfer is taking place? From what area the heat transfer is taking place? The heat transfer is taking place from the outer surface area. So what is the total outer surface area? Pi d into L. Pi d into L. That is the outer curved surface area. Okay. So pi d into L. So pi and d is 0.08. 0.08, and what is L? L is 6 meter. L is 6 meter. So if you calculate the heat transfer area, it will come out to be 1.508 meter square. So area you know, H you know. So what is heat transfer? H AS delta T. Very good. Only one relation is there. Only one relation is there. What is H? 5.869. What is AS? 1.50 H. And what is delta T? Delta T is 70 minus 20. delta T is 70 minus 20. So if you add all those things, you will get your heat transfer to be 443 watt. My dear friends, see, the questions are seemingly, you will feel that it is very lengthy. It is, but if you do such questions over here, trust me, in the examinations you are going to be very, very comfortable. This much big or I would say tricky questions may come, might not come. That is not the issue. But you need to be confident to face any question in the examination. For such only we are doing such sessions. We are purposefully putting difficult questions. Right? But it is also going to tell you that how good is your preparation. Right? So I think we have done sufficient number of questions from convection, and I'm sure that whatever question comes from convection, you will be in a very, very good position. Okay. Okay. Now I think we should move towards see, conduction we have already done. Heat exchanger ka beech mein not many, but I think one question we have heat exchanger we have done. Convection we have done many questions, and now convection mein we have covered all the types of variety we have covered. That means external force also we have covered, internal we also covered, and free convection also we have covered. That is also we have covered. So I think we are left with only one big chapter, what is the major chapter, and that is nothing but your radiation. Once the radiation is done, I can at least say that I have covered, almost all the chapters that is there in your heat conduction. Let us start in 1 minute. Let us start the session in the next 1 minute. Yes. Okay. Okay. So now let us, I think we should start with our, the heat transfer radiation questions. So my dear friends, let us complete the last chapter also in a very good manner. Okay. Here is the question for you. I am giving you 2 minutes of time to study. Okay. Please read the question. So the question is saying what? He is saying that consider a conical enclosure of height h and base diameter d. Determine the view factor from the conical side surface to a hole of diameter d located at the center of the base. So this is a conical enclosure. In the center, one hole is made of diameter d. And that he is saying what is the view factor. Okay. So something like this is the figure and numbering also. So what he is asking? He is asking F31 or 13. F31 he is asking. Okay. He is asking F31. My dear friends, only focus one. One is what? The whole of diameter D. Of diameter D. What is 3? The conical surface. The conical internal surface. Okay. My dear friends, can I directly apply this relationship? The reciprocity theorem. The reciprocity theorem, can I directly apply? Yes. A1 is what? The whole area. So pi by 4 into D square. What is F13? F1113. It's a flat surface. When it's a flat surface, it will be 1 only. It is 1 only. Okay. Now what is A3? F31 I need to find out. That is not the issue. But what is A3? What is the curved surface area of the cone? Pi RL. Pi RL. Diameter by 2. RL. What is L? L is the slant height. L is the slant height. What is L? Slant height. So root over h square plus, so something like this. So this is d by 2 square. So d square by 4. This is the slant height. This is the slant height. So pi by 4 d square into 1 is equal to pi r l h square plus d square by 4. Pi r l into F31. My dear friends, I think from here we can simplify. From here, I think we should simplify. See, one thing is there. Suppose, I'll tell you a good thing I have observed over here. Sometimes you will see what? A very small, options may very small, answer is given. Not in the form of root over sine, something like that. He has not given. So how could have he possibly simplified? How could he have possibly simplified? That we are trying to understand. See, this d square by 4 term, he has assumed very, very less than h square. Then, how? So it is very less. So better write h square only. F31. So pi by 4 d square is equal to pi d by 2 root h square into h into F31. So pi and pi gets gone. It is 2. So what we are left with? What we are left with? What we are left with? D square by 2 dh. D square by 2 dh. Yes, something like this. This I am saying that suppose he has given this as the answer. No root sign is there. So how could he be possibly simplified? That I have shown. So very easy. You can definitely expect one question from the view factor. Last year also there was one question. This is also. So that's why we have covered view factor also. Okay. So I think it was not a very tough question. It was a relatively easier question, and without wasting any time, let us move towards the next question, my dear friends. We are not wasting a single time. Question after question, good questions after good question, my dear friends. It is up to you how much you can absorb. So don't get confused by this. This is not 15 feet. Actually, it is meter. 15 meter I have given. In the original question it was 15 feet, but I have changed to meter. No issues, that is not the issue. Okay. So what is the question saying? The question is saying that a furnace is shaped like a long semi-cylindrical duct of diameter 15 meter. Okay. Diameter 15 meter. The base and dome of the furnace have emissivities. Base having a emissivity of 0.5 and dome is having a emissivity of 0.9 and are maintained at uniform temperature. Base itna and dome at this much. Determine the net rate of radiation heat transfer from the dome to the base surface per unit length during steady operation. My dear friends, see, two surface enclosure it is there. If it is a two surface enclosure, you know what is the formula. What is the formula for two surface enclosure? Sigma T14 minus T24 divided by 1 minus epsilon 1 by A1 epsilon 1 plus 1 by A1 F12 plus 1 minus epsilon 2. Now over here it does not matter that which one you have taken as 1 or which one you have taken as 2. It does not matter. Answer or the magnitude you will get it to be same. Obviously there will be plus and minus difference. That is very much obvious. So let's say but one thing is there, my dear friends, one thing is there, that suppose that this is the, see, it is a very important point as far as your examination is concerned. Let's say this is the base. And this is the dome. If you have taken your dome as 1 and if you have taken base as 2, so definitely when you have written A1 F12, so if you try to find F12, then you need to find the view factor separately. But I will take it in such a way that I need not find the view factor. Why? Because if I take the base as 1, no issues, and if I take the dome as 2, what is F12? It is 1 only. It is 1 only, flat surface. So that way, and you know A1 base area I can very easily find na. Suppose you would have taken A1 as the hemisphere, so thoda sa it is difficult. But now base I can very easily find. So try to take in such a way so that you have to do minimum calculations. This is what I want to say over here. Right? Is this clear? Is this point clear? Even if I need to find, area of hemisphere, that is not a very big task that I anyway have to find. That is not the thing. But I hope you got the point. Okay. So simply I will be putting or substituting everywhere. So what is sigma? Okay. So 5.67. So I have not calculated this entirely. I will be simply putting the values and leave it for you to calculate. What is T1? T1 is, let's say, 550. Now don't get confused by R over here. It is just, I have given Kelvin in the question. So consider Kelvin. 4 to the power 4 minus 1800 to the power 4. Sigma T1 4 to the power T2 4 by 1 minus epsilon 1. That is 0.5. 1 I have considered to be the surface. 0.5. Areas was 15 per unit length. Per unit length. So 15 into 1. 15 into 1 plus 1 by A1. 15. F1 I told it is 1 plus 1 minus epsilon 2. It is 0.9 by what is area? Pi RL. Area pi d by 2. Pi d by 2. pi into d by 2 into distance length L into epsilon 0.9. Now I am leaving the calculation up to you. This you have to calculate, and my dear friends, I can tell with certainty that you are going to get a negative answer. So no need to panic. The heat transfer rate is same magnitude wise. So just for it is from the one that I have considered, it is from 1 to 2, that is from base to dome. Okay. But when you calculate from dome to base, so definitely you will put a minus sign and then you will get the answer as positive. So I am not calculating the entire thing because calculation, my main agenda is not to show you how it is done calculation wise. Calculation, I am sure that you are better at it, and my only job is here to tell you the concepts related to it, right? So I am expecting that you will be solving this and letting the answer know in the comment section. And meanwhile, just check this once, and meanwhile we will be proceeding towards the next question. Okay. So here is, my dear friends, one question from radiation shields. I'll tell you, view factor we have done. From radiation, view factor question we have done. Heat transfer radiation networks question also we have done. Yes, the last question was from radiation networks only, where space resistance, surface resistance, all will be there. That also we have done. But radiation shields is another important topic which can come in the examination, and this is the question from radiation shields. Right. So please read the question. Please read the question, my dear friends. Please read the question. Please read the question. Try to give the answer. Try to give the answer or concepts. Okay, so let us discuss. Two very large parallel plates are maintained at uniform temperatures of T1 is 1000 Kelvin and T2 as 800 Kelvin, and have emissivities at epsilon 1. This is epsilon 1, no issues. This is epsilon 1 and this is epsilon 2, both as 0.2. Let me say, it is desired to reduce the net rate of radiation heat transfer between the two plates by one-fifth by placing the thin aluminium sheets with an emissivity of 0.15 on both the sides between the plates. Determine the number of sheets that needs to be inserted. Another very brilliant question of radiation shields, my dear friends. Another brilliant question. I request my dear friends to read the question again. I request my dear friends to read the question again before I start solving. I want you guys to read this question again. So he is saying that when you place some N shields that should be 1/5 of the Q when no shields are there. This is the most important information that we can extract. Yes or no? This is the most important information that we can extract. Can we find Q with no shields? Yes, definitely. Why not? Q with no shields. Do we know the formula? Do we know the formula? Yes, we know. Flux, if I ask, it is sigma T14 T1 to T to the power 4 by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. So this we already have studied many times. So yes, there's the figure that you can see over here. So let's say what is Q with no shields. So Q with no shields is nothing but sigma 5.67 into 10 to the power minus 4. What is T1? T1, let's say I'm considering the higher one. Power 4 minus 800 to the power 4. 1 by epsilon 1. 1 by, what is epsilon 1? Both are same in this case, that is not the thing. 1 by epsilon 2, that is also same, minus 1. Minus 1. Okay. Anyone can give the answer? Anyone can give the answer? So if you solve it, you will be getting 3720 watt, not watt, per meter square. Why? Because I have calculated the flux. That means for a unit square area, 1 meter square area, we are finding. Okay. Now, my dear friends, before I write the formula, see, suppose that this is the first plate and this is the second plate. These are the two plates, and initially no shields are kept. Now imagine that I have inserted one shield. I have inserted one shield to reduce the rate of heat transfer, which is the purpose of the shield. I have introduced. Now what changes you see in the formula? Definitely 2 extra surface resistance and 1 extra space resistance gets generated. This is how we learn this concept. 2 extra surface resistance and 1 extra space resistance gets generated due to placing this shield, and this is how we learn. And what is the then, let's say, Q with 1 shield. So again, sigma T14 minus T24 I have inserted, and then 1 by epsilon 1 plus 1 by epsilon 2 minus 1. How we know? Now wait, now see. For one extra shield, see, 1 by epsilon 3 to 1 plus 1 by epsilon 3 to 2 minus 1. Now this is for one shield. If you insert 2 shields, you would multiply here by 2. If you insert 3 shields, you will multiply by 3. And if you insert n shields, you will multiply by n. This is how we have to remember. And that is, he is asking, what is the value of the 10? Now Q with n shields, here I am writing n shields. So do I know this? Yes, I know that this is the 1/5 of 3720. 3720. So let me take to the next page. So once again I am writing the formula. Q with, see, this is how we have to memorize the formula, the concepts. Simply if you memorize, it will not have a very good outcome. Okay, so Q with n shields, it's sigma T14 by T24 divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 1 plus n shields and 1 by epsilon 31 plus 1 by epsilon 32 minus 1. This we already know that this is 1 by 5. 1 by 5, 3720. This is of 3720 and sigma now all the things you have to put, substitute 5.67 into 10 to the power minus 8, and what is T1? All the things are same, only the 1000 and 800. This is 1000 to the power 4 minus 800 to the power 4 divided by, what is epsilon? Epsilon I think is 0.2. 0.2 minus 1 plus n I don't know. N I don't know. Now that value, epsilon 31, epsilon of the sheet is given 0.35. 0.15, sorry, 0.15 plus 1 by 0 point plus 1 point minus 1. And my dear friends, when you solve it, please solve and let me know what is the answer. Please solve. So my dear friends, when you solve it, you will be getting your n value as 2.92 and which is equivalent to 3. It is equivalent to 3. So my dear friends, this is the number of shields which you need to list, right? So just see, I told you that first of all this question is done. We have got the answer 3. And now my dear friends, see, whatever questions I have taken today, first of all, it has covered almost everything. Almost. I'm not saying 100% of the topics have been covered, but more than 90% of the important topics that will come in examination have been covered. That too without wasting any single time. I have taken the question, given you 2 minutes of time to solve, and I have solved it over here. Yes, some calculations I have left it for you, but I expect you to solve them and let me know in the comment section how to proceed. Some 12 to 14 questions that I promised in the beginning, good questions, one of the best questions of HT I have covered over here, right? So what I request is that even if you couldn't watch the session live from today, what I request is that please do watch it after you think to revise HT, because you will do many you will give many test series. All you need, see, what is your requirement from the student point of view? What is your requirement? Your requirement is, sir, someone please give me all the best questions so that I save my time searching for them. So you go here and there searching for those questions. This is where I have saved your time. So I request everyone that whenever you think to revise your heat transfer, please do watch this session. This will prove to be very beneficial. Can prove to be very beneficial. Okay. So again, if you ask me what topics I have covered from the radiation part, I have covered view factor, I have covered heat transfer rate, then I have covered what? I have covered radiation shields, then I have covered what? From convection, internal convection, forced convection, free convection, that too I also have covered. Conduction, generation, fins, one of the best question of fins that you will come across. All the best questions I have covered, my dear friends, of all the chapters. I don't think that any chapter is left. Okay, I remember, yes, I remember that one heat exchanger question I told you that I'll be taking at the end. Yes, I do remember. Don't worry. Whatever questions I have brought, all the things will be solved. Yes. Yes, this is the heat transfer question, heat exchanger question that I told you that we'll be solving at the end. Yes. Please read this question. Please read. Please read this question. Okay, so let us discuss. So my dear friends, he is saying that a counter flow double pipe heat exchanger, counter flow, this is the important thing, heat exchanger is to heat water from 20 degrees centigrade to 80 degrees centigrade. Okay, so counter flow is so 20 to 80, so counter means reverse. So geothermal is to be, the heating is to be accomplished, water is heated, it is to be done by geothermal water available at 160 degrees centigrade at a mass flow rate of this. So I think mass flow rate of both the fluids he has given. Okay. Has he given the exit temperature of geothermal? Has he given the exit temperature of geothermal? No. He has not given this, so we need to calculate this. Okay. The inner tube is thin walled and has a diameter of 1.5 centimeter. Very good. If the overall heat transfer coefficient of the heat exchanger is 640, okay, overall heat transfer coefficient is 640. Overall heat transfer coefficient, determine the length of the heat exchanger that is required to achieve the desired heating. Very good. So I think I can sense one thing that ultimately I need to calculate the area somehow. Area से pi dl करेंगे, pi dl से length मिलेगा. That's it. That much of sense will come when you solve many questions. Okay. Properties that we take the specific heat of water and geothermal fluid to be this and this respectively. Okay. So my dear friends, LMTT method से करें. LMTT method से how should we proceed? LMTT method से how should we proceed? First of all, LMTT के लिए what is the formula? LMTT के लिए counter flow है, so delta Ti minus delta T out divided by ln delta Ti by delta T out. Do we know all the four temperatures? No. I don't think we know all the four temperatures, so no issues. So heat lost equal to heat gain. Heat lost equal to heat gain. So cold water is being heated, so geothermal will be losing. No issues. Geothermal will be losing. Okay. So m dot. So do we know all the data? So right hand side we know, gain wala we know. So no issues. So m dot Cp T in minus T out for the geothermal water is equal to m dot for cold water, cold, Cp of the cold, and how much it is exit of cold minus inlet of cold. So I think we know this 1.2 geothermal का mass flow rate how much? 2 kg per second. Sorry, that is the 2 kg per second. 2 kg per second. What is the CP? What is the CP? 4.31. What is TI? 160. 160. T naught I don't know. T exit I don't know. M dot cold is 1.2. CP is 4.18. And from where to where? 20 to 80. So 80 minus 20. 80 minus 20. So this will come out to be 301 kilowatt. This will come out to be 301 kilowatt. And finally, when you T naught of geothermal, when you find out, it will come out to be 125 degrees centigrade. So the fourth temperature we have calculated. Fourth temperature we have calculated. Okay. So from here it is how much? 20 to 80. Okay. 20 to 80. So this is 20. Cold water. This is 80. And counter flow hai. So this is 160. And this is 125. Isn't it? 125. Okay. So what is delta Ti? Delta Ti is very easily you can find out 20 minus 125. Or positive wala lete hain. Positive if I take. So 125 minus 20. So what is this? 105. Delta T out, if I ask you positive, if I take 160 minus 80, so it will come out to be 80 only. So delta Ti, delta T naught, I have already found out. So can we calculate delta Tm? Delta Ti. What is delta Ti? 105 minus 80. Delta Ti minus 80 by ln 80. Okay. So what is LMTD? What is LMTD? LMTD will come out to be 92 degrees centigrade. Okay. LMTD हो गया. So LMTD हो गया. So you know Q is equal to UA delta T. Q we already know. Heat, actual heat transfer how much? 301. 301. Okay. What is overall heat transfer coefficient? Overall heat transfer coefficient is given as 640. 640. 640. Wait, 301 is the kilowatt. 301 we have got kilowatt. 301 kilowatt. So we have to write 301 into 10 to the power 3 watt. So this is 640. Now area. Area we need to find out. And what is delta? 92. Delta is 92. Now don't think sir Kelvin we have to put. No, it is a temperature difference. Temperature difference. Logarithmic mean temperature difference. Logarithmic mean temperature difference. So it is whether you write degree centigrade, whether you write Kelvin, that is the same thing. Okay. Area, what is we are getting? Area we are getting close to 5.11 meter square. Area we are getting close to 5.11 meter square. Okay, pi dl. He is asking the length. He is asking the length. No issues. Pi dl. Pi dl kar do. 5.11. 5.11. Do we know the diameter? Do we know the diameter? Diameter, do we know? Okay, very good. 1.5 centimeter done. 1.5 centimeter, very good. 1.5 centimeter, very good. So pi 1.5 into 10 to the power minus 2 into length is equal to 5.11. Anyone with the length? Anyone with the length? How much length we are getting? How much length we are getting? Anyone with the length? Anyone with the length? I have not done the calculation here. Anyone with the length? Length? No one? No one? So I am leaving this to you, leaving this up to you. Whatever length you get, Whatever length you get, I'm leaving this up to you. Whatever length you give me the answer. Okay. My question to you is, this is done. The question is done. The question is done. The question is done. My question to you is, could have we solved by effectiveness NTU method? My question to you is, could have we solved using effectiveness NTU method? This this we solved by LMTD method. LMTD method. Okay, this we have solved by LMTD method. But could have been we solved by effectiveness of NTU method? See, I know the mass flow rate and Cp of both the fluids. So I could have calculated C for, that is the capacity rate, heat capacity rate for cold fluid and C for the hot fluid, yes or no. From there I could have calculated the capacity ratio, that is the C minimum by C maximum, yes or no. I could have calculated the capacity ratio, C, very good. Maximum heat transfer rate I could have very easily found by C minimum into TH max minus TC minimum. So Q max I would have known, Q actual I already know, I have found out. So could have I found the effectiveness? Could have we found the effectiveness? That is Q actual divided by Q max. So effectiveness मिल गया. I know the C. So do we have relations of NTU? Do we have the relationship of effectiveness as a function of NTU and C? Do we have the relationship na, effectiveness as a function of NTU comma C for a counterflow heat exchanger, that a big expression comes. So from here NTU you would have found out, you know the two things, NTU मिल जाएगा. NTU is what? What is NTU? Once you know what is NTU, then I know it is UA by C minimum. NTU is nothing but UA by C minimum. C minimum I know, U I know, area I could have found out. Once you know the area, simply apply pi dl and you will get the value of L. So whether you apply, my dear friends, whether you apply the LMTD method or whether you apply the effectiveness NTU method, you would have got, from both the methods you would have got the value of L. Now what I want that you solve this question by effectiveness NTU method and tell me that whether you are getting same answer or different answer in this case. Yes, we should get the same answer. If you are not getting the same answer, let me know. Right? So my dear friends, I think now all the topics I have covered, whatever questions I have come up with, some 14-15 questions and in one question so many interrelated questions were there, my dear friends. All the questions I have covered with the solution. Yes, I have asked you to do something from your end also, some calculations I have asked, but I think conceptual wise all the questions I have discussed. And my dear friends, again I'll only tell you one thing. If you are seriously preparing for GATE 2024, so I request everyone that when you think of your final revision of heat transfer, please to watch this session. It is definitely going to benefit. It might be possible that some of these questions might be same as, it might come the same as in the examination, right? So please, if you are finding this useful, please share it with your friends who are also preparing for GATE 2024 seriously. And if you like such sessions from my end, please let me know in the chat box. I will come up with more such sessions. But if you are not enjoying, then I will not work so much hard collecting the questions. So anyway, so do let me know how you felt about this session. And in case of any questions, if you have any conflict, you can ask in the chat box itself. So this is where I will be stopping, my dear friends. My name is Sourav Upadhyay. I'm a senior mentor at the IMS Gate Academy. So for any queries, you can let me know. There is not at all any issues. Right? So we have completed this vast journey of question series of heat transfer, wherein I have covered all the chapters in the best way possible. Right? So once again, my dear friends, I request all of you to join our Telegram group. Therein, we'll be posting many quizzes, questions every day, and with government job notifications also. So you can please, you can definitely benefit a lot from there. These are online program. You can watch it. These are the program features. Click the link in the description if you want. If you want counseling session, that is also possible. So my dear friends, with this, I I conclude this session, and I wish all of you very best of luck for your GATE examination. And my dear friends, I'll be coming up with one more session on industrial engineering. Next week, same day, same timing, I'll be coming up with industrial engineering, where I'll be discussing many questions, and through that you will be able to revise that subject in a span of 3 hours. So my dear friends, I'm not going to waste that much of time. Wish you all the best in heat transfer. Stay connected, stay safe. God bless. Thank you. Good night.
I'll give the PDF, sir.
PDF is available.
Put Telegram, sir.
When you will give?
Now only. Put Telegram, sir.
तो मेरे को WhatsApp कर दो.
WhatsApp or I'll just give you type, sir.
WhatsApp Telegram कर दो. I'm closing everything.
I'll WhatsApp, okay, sir.
I'll share it in my Telegram. Okay.
Official group.